Alright, so let's start with common factoring. Okay, so you already know it. So first we look at all the terms, okay, and consider so look at the numbers first, find the common factor, and then look all different variables. So we see that, for example, 3, 3, and 6, they have a common factor of 3, so we take it out. Then we'll look at the variable c. So c cubed, c squared, c. So we have to take the one with the lowest exponent, right? So we get the c out. Then we look at the variable d. So we have d squared, d cubed, d to the power of 4. So the lowest exponent is 2, so we factor that out. Then what are you going to write in the bracket? So take each term and we divide it by this common factor. So if you divide the first term by that, right? Okay, so 3 and 3 is gone. C cubed divided by c is c squared. D squared divided by d squared is gone. Okay, so negative sign. Now we look at the second term. So divide the second term by that common factor. 3 divided by 3, 1. C squared divided by c gives you c. D cubed divided by d squared gives you d. Okay, so minus. Now let's divide the last term by the common factor. So 6 divided by 3 gives you 2. C divided by c gives you 1. D to the power of 4 divided by d squared gives you d squared. Okay. Then check if you can factor this further. When you look at this, it's a trinomial, right? So how do you factor the trinomial? So check if it is possible, right? So this is negative 2. So the factors of it is, it can be negative 2, positive 1, or positive 2, negative 1. Oh, you know, the difference between them looks like matches with this, right? Negative 1. So again, so this is, the factors could be positive 1, positive 2, negative 1, or negative 2, positive 1. So when we add these two, we get negative 1, which matches with the number in front of the middle term. So then we factor it, right? C and C, and the other one is gonna be, there's gonna be D and D. Okay, so then again, so this is giving us the match for the middle term. So one of them is gonna get negative 2 and the other one is gonna get positive 1. So now we have fully factored. Okay, so let's look at the next one. So this is factoring trinomials. Okay, so we try to use trial and error method for this. Okay, that is the shortest way of doing it. I know some of you, maybe, I don't know if you learned decomposition method, but we really prefer to do it using the trial and error method. Okay, so the first thing I want to do is putting it in descending order. Means put the highest exponent first and then go from there, right? So I'm going to put negative y squared plus 7y plus 8. This is the first step. Second step, if the first term have a negative value, okay, in this case we have a negative leading coefficient, so factor that negative sign. Alright, this is the second step. So negative y squared, so you change the sign of all the terms here. Alright, now we factor the inside. So we have y squared minus 7y minus 8. Again, you check for the factors of 8, the last number, right? So that could be 1 and 8, 2 and 4. So looks like 1 and 8 is going to work for us, right? Negative 8 and plus 1, when you multiply, get negative 8. When you add them, you get negative 7. So it looks like that is going to work. So we factor it as y minus 8, y plus 1. Yes?
The 8 minus y or 1 plus y work too?
Sorry, I didn't get the question.
Does 8 minus y and then 1 plus y work too?
It will work, but I don't recommend you to do that right away. So therefore, see, I put them in descending order. Factor the negative sign. Okay. We usually want, when you look at the factors, we usually want the variable with a positive value in front of it. And because when later on, especially when we need to find the x-intercepts, it becomes much easier. Okay, it may be harder to see it from here. It's not wrong, but again, so this is much better in terms of seeing the factors, finding the x-intercepts and stuff.
Please excuse this interruption. This is just a reminder to teachers who have not yet done their attendance to please do so using web attendance as soon as possible. Thank you very much.
Okay. Now, let's look at the next one. So we have 8x squared minus 10x minus 3. So check for the common factor. We don't have one, right? Okay, no common factor. Then it is in descending order, but the leading coefficient is not 1, so this was easier to factor, but now the leading coefficient is 8, right? Now, not only you have to consider the factors of the leading coefficient, and also, you know, two numbers to consider, right? The factors of the last number and also the leading coefficient when you are factoring. So what are the possibilities, right? So 8, so there is 1 and 8, right? Second possibility, 2 and 4. That's it. So 3 is only factors of it, 1 and 3. Then you will try, right, which one works. So it's again trial and error method that we are trying to do. So when you're trying, I recommend you to start with the numbers that are closer to each other. So in this case, instead of starting from 1 and 8, I would start with the numbers 2 and 4 because they are closer to each other. It may not work, but usually that is, you know, there is more possibility to get with the numbers that are closer to each other. Okay, so that first I'm going to try 2 and 4. If it doesn't work, then I'm going to go and try 1 and 8. So let's try 2 and 4. Okay, so we have 1 and 3. So let's say if we put 3 here, 1 there, what happens? Does it work? 4 and 6. Oh, looks like we may be able to get 10, but let's see, right? We are not sure. We are just gonna try. So then let's say put negative here, positive 1 there, 4, negative 6. Nope, it didn't work, right? We get 4x from here, negative 6x from there. When you add them, you get negative 2x. So it didn't work. So this didn't help us, okay? So how about if we put 3 here and 1 there? So let's try that, right? So 3 and 1. So what do we have now? We have 12x and we have 2x. Okay, so that is positive 12 minus 2 gives us positive 10. Oh, looks like I'm getting 10, but not the right number. Therefore, just I'm gonna switch these numbers here now. So negative and positive. Now we get negative 12x plus 2x gives us negative 10x. Are we okay with this, or do we remember those from last year? If you want me to go over, please, okay, just tell me. So then I go over. Alright, so then we factor this. 2x minus 3 and 4x plus 1 is the answer. Okay, let's look at the next one. So now we have 2m cubed plus 7m squared minus 30m. So first look for common factor. So in this case, m is a common factor. So take that out first. Okay, so 2m squared plus 7m minus 30 we get. Next, again, it's a trinomial. We look at the factors of the leading coefficient, and we also look at the constant at the end, factors of the constant at the end. So factors of the leading coefficient. It is only one possible answer, right? M and 2m. Okay, so m, 2m. Now let's look at the other numbers. So what are the factors of 30? 1 and 30, 2 and 15, 3 and 10, 5 and 6, right? Those are the possibilities. Correct? Can you guys see it from there? So now I'm checking the factors of 30, right? 1 and 30, 2 and 15, 3 and 10, 5 and 6. That's all, right? Those are the factors. Again, where do we start? We start from the numbers that are closer to each other. So I'm not going to start from 1 and 30. They are the farthest, right? Compared to 5 and 6. So I'm going to start from 5 and 6. If it doesn't work, I'm going to try 3 and 10. If it doesn't work, I'm going to use, try 2 and 15. And goes. Okay, so I'm going to try now 5 and 6. But look at this 2m, right? I cannot put 6 here. That means that, there's a common factor there, 2. But originally, we don't have a common factor 2. So there's no point of trying the 6 in this bracket, in this factor. Okay? Are we okay with that statement? So, we have factors, and now we're going to use numbers 5 and 6, and we're going to place them here. But again, I cannot use the 6 in this bracket, in this factor, because if I put 6 here, means 2 is factorable. But, see, originally 2 is not factorable, right? That is the reason I cannot use the 6 here, because 2 is not a common factor. So I'm going to use 6 here, and 5 there, and try. Okay, what do we get? So 12 and 5. Okay, looks like it's gonna work, right? 12 minus 5 gives you 7. So 7 is a positive value, then 12 must be positive and 5 must be negative, right? So that you get 12m minus 5m gives you positive 7m. Alright, so these are factoring trinomials. So next one is factoring perfect square trinomials. Okay, so means that you are gonna get a square of a binomial, right? So that's when you factor it, you're gonna get square of a binomial. So check, right? If is the leading term a perfect square, right? So looks like 81x squared is a perfect square. So that is 9x squared. Then you check the last constant, 64. Is it a perfect square? Looks like it is, right? It is 8 squared. Okay, now I can see that we could have a perfect square trinomial here. But how do you check if it is a perfect square trinomial? So you multiply these two and multiply by 2. Okay? Because let's remember, let's say you have a plus b square. How do you factor that, right? A squared plus 2ab plus b squared, correct? So how do you get the middle term? You multiply the square root of the first term, square root of the last term, and you multiply these by 2, right? That's how you get the middle term, right? So that is the reason. So when I'm checking if this is a perfect square or not, right, I'm gonna take the square root of the first term, take the square root of the last term, multiply them, and multiply them by 2 to see if it matches with my middle term here. Okay, so 9x times 7, right? 8, sorry. Where did I get the 7? 8 gives us 72x. Then we multiply it by 2. So we get 144x. Oh, it's perfectly matching with the number that we have here. So this means that this is a perfect square trinomial. So then you factor it as 9x and 8. Okay. Okay, what sign you're gonna put here? Positive or negative? If the middle term is negative, you will put a negative. If the middle term is positive, then you will put a positive. In this case, it is negative, so I put a negative sign. So then square it. So 9x minus 8 squared is the factor of. Are we okay with this? Any question? All right. Now example 6. So again, anytime when you need the factor, check for the common factor first. Okay, that is the first step that you should be taking. So we see here 18, 24, 8, looks like 2 is a common factor. So factor that out first, 2. Then divide each term by the common factor. So we get 9a squared 12ab plus 4b squared. Okay, then check if the first term is a perfect square, right? 9a squared, well, that is 3a squared. Then check the last term. We have 4b squared, well, it is 2b squared, so it's a perfect square too. Then you are suspicious that this could be a perfect square trinomial. Okay, then what do? So you take the square root of the first term and take the square root of the last term, multiply them, and be multiplied by 2, right? Again, so you have 3a, 2b, multiply. You get 6ab, multiplied by 2, 12ab. It is perfectly matching with the middle term. Okay, then factor this. So 2, 3a, 2b. What's going to be the sign? Middle term has a positive sign, therefore I should have a positive sign here. Okay. Next type of factoring is group factoring. So we have group factoring if we have 4 terms. Okay, that's the case. So 4 terms. So check 1, 2, 3, 4. Okay, this one has 4 terms. Then you put the terms in groups. Okay, in groups of 2, but not always you have to put, let's say, first and second term together and third and fourth together. Maybe you may need to put first and third together and second and fourth together, right? So the order you can change. It is not always, oh, I'm gonna put first 2 terms together and last 2 terms together. It may not work. So in this case, for example, if I put the first 2 terms together, can I factor anything? Looks like no, right? So therefore I should not be even trying that, because I cannot factor anything if I put the first 2 terms together. So what I'm gonna do, maybe I'm gonna put first and third together and see what happens, right? X squared. So, but when you are putting them together, always take the terms with the sign in front of them. Okay, so I'm taking x squared and xy. All right, positive. Don't bother putting the negatives yet. Okay, put them inside the bracket first, then if you need to factor it out. So we have negative y minus x. Okay, now we put them in groups, then factor whatever you can. So in the first bracket we see that x is a common factor. Okay, so from the first bracket I'm going to factor x. So what do you have done? X plus y. Okay, now let's look at the second bracket. We have negative y, negative x. I can't factor a number, I cannot factor a variable, but only thing I can factor is the negative sign. Okay, so negative 1, negative 1, so it's a common factor. So I'm going to take the negative 1 outside. You can write negative 1 or you can just put a negative sign. Okay, but even you put a negative sign, make sure you know that this is negative 1 that you're factoring. Okay, then negative y divided by negative 1, you get y, and negative x divided by negative 1, you get x. So you have y plus x now. Okay, so in the from the first one we have x plus y, and in the second one we have y plus x. Now what is the common factor, right? X plus y and y plus x are the same thing. So you can factor now x plus y. Okay, so then that's what you do, right? So you have two terms. So term 1, terms are separated by negative and positive signs, right? This is your term 1 and this is your term 2. Okay, so take the term 1, divide by common factor. So you get x only if you divide it. And now take the second term, negative 1, y plus x divided by x plus y, and this is gone, right? You get negative 1. There we go. It is factored. Now next one. Factoring difference of squares. Okay. So if you have something like this, so you should check. So this is only works with two terms, right? And if there's a negative sign. So in this case, so first check, of course, if there's a common factor. Factor that out. If no common factor, then you check the first term and second term and check if they are perfect squares. In this case, they are, right? So 225b squared is 15b squared. And a squared is a squared. And there's a negative sign between them, means that we can factor it as difference of squares. So that is 15b minus a, 15b plus a, right? One with a negative sign, one with a positive sign. Okay, next one. So how many terms do we see? Okay, so this is 9 times 2a minus 7 squared. So this whole thing is a one term, don't forget, right? And 4 is another term, and there is this negative sign between them. Now you're suspicious, oh, this could be a difference of squares, right? Then check if each of them is a perfect square. Okay, 4 is square of 2, and this one is, so square root of 9 is 3, square root of 2a minus 7 squared is 2a minus 7. Okay, so now the second term is the square of 3 times 2a minus 7, right? Now looks like this is a perfect square, difference of squares. Now we are going to factor based on that. How do you factor difference of squares, right? So if you have a square minus b square, you factor it as a minus b, a plus b, right? So now what is my a? My a is 2. My b is 3 times 2a minus 7. Are we okay with this or confusing? Okay, so look at, so we took the square root of each term here. So 4 is a square of 2, and this one is square of 3 times 2a minus 7. Okay, now if you compare this with a square minus b square, okay, or we could do, if you don't want to get confused with this a, you could also use x square minus y square, x minus y, x plus y. Okay, then you can see that x is matching with 2, y is matching with 3 times 2a minus 7. Okay, now let's factor it as x minus y, x plus y. Okay, so x we said is 2. Okay, 1 with negative, and we said y is 3 times 2a minus 7. And now 2, 3 times 2a minus 7, but this time with a plus sign. Okay, so this is the formula. But are we done? No, we need to simplify it, okay? Because see, there's a bracket in a bracket, we don't want to have that. So we're going to expand the brackets here, okay? So to distribute this -3, so -3 times 2a, -6a. -3 times -7 gives you 21, okay? And now let's do the same thing for the second bracket. 2 plus distribute 3. 3 times 2a, 6a. 3 times -7, -21. Okay? Now collect the like terms. You are still not done, because in each bracket, look what you have. 2, 21, right? So you are able to collect those numbers. So you get 23 minus 6a, and then you have 6a minus 19. Okay? Now they are all collected. We could do one more step. Again, we prefer that the variables in each bracket have positive values in front of them. This second factor, as you see, is 6a minus 19, so which is very good. But the first one, you know, 6a has a negative value in front of it. So you can just factor the negative sign as well, and that would give you negative 6a minus 23 from the first bracket and 6a minus 19 from the second. And now finally it is completed. Right? Well, there is another way of doing this. Okay, what is that? But we don't prefer that, but I'm just gonna say it anyway. If you distributed this, right, so you take the square of 2a minus 7, then you multiply it by 9, then you subtract those from 4, and you get a trinomial. If you factor the trinomial, you should be also getting this. But look at the numbers, right? 23, 19, they are very big numbers. Do we really prefer that? Right? We do not, if possible. So this is the best way of doing it. Okay, that's the example on this sheet. We have m to the power of 8 minus 1. Now we are going to factor that, right? So check again if these are perfect squares. M to the power of 8 is square of m to the power of 4, right? And 1 is a square of 1. Can you guys see? Okay, here we go. Now let's factor this. Right? Your x is now m to the power of 4. Your y is 1. So when you factor it, you get m to the power of 4 minus 1. M to the power of 4 plus 1. Okay, are we done? No. Because m to the power of 4 minus 1 is difference of squares again. Right? This is not m to the power of 4 plus 1, because there is a plus sign between them. So that doesn't work. But the first factor works, right? It is again difference of squares. So m to the power of 4 is the square of m square, right? So let's factor this one again, m to the power of 4 minus 1. So that gives us m square minus 1, m square plus 1. Okay, we still have this here. Are we done? No. M square minus 1 is again difference of squares. Okay, so we factor that now. So m square minus 1 is m minus 1, m plus 1, and of course we have those two factors here, right? M square plus 1, m to the power of 4 plus